Hello everyone, my name is Dr. Nagaraju, working as an assistant professor in the Department of Computer Science and Engineering, Artificial Intelligence and Machine Learning in the Institute of Aeronautical Engineering, Hyderabad. So today I am here to present one of the chapter or one of the important topic in module 5, which is called as expert system. So in the earlier sessions we have discussed how the planning can be done while we are training the artificial intelligence machines, and also we have learned how the learning procedure in the artificial intelligence machines will be. So, and we have seen some of the options, we can say, how that artificial intelligence machines will learn. Okay, for example, we have identified some of the learning procedures like through memorization the AI machines can learn, through examples it can learn, through problem solving it can learn, and through experience also it is going to learn. In this today's session, we are going to concentrate on the other aspect of the expert system. So we can say that this expert system is a little bit different from the planning and learning approaches. So what this expert system will do, and how these expert systems are going to be implemented, we will try to cover in this particular module. And coming to the today's session, our concentration will be mostly on on the aspect of expert system and how these expert systems will be developed, and what kind of activities that will be happened while developing the expert systems. And we are also going to see some of the examples where these expert systems are already implemented, and we are going to see the functionalities of those expert systems. So let us move into the concepts. And we talk about these expert systems. As we know that for every artificial intelligence machine, it is very important to have a expert system. Until and unless we have an expert system, we cannot make a machine to behave intelligent. But the biggest question is what makes an AI machine to behave intelligent. So in the earlier modules, we came to know that the exhibiting of intelligence by a AI machine can be done by providing the knowledge. Means whatever the knowledge that we are providing to the AI machines, that knowledge is going to implement by that machines to exhibit its intelligence. And also based upon the knowledge, the AI machines are going to learn something, and by learning also it is going to get some new knowledge, and that exhibiting of new knowledge, again it will show the intelligence of those machines. But coming to here, what is the point means how the AI machines are going to get the knowledge. So as we know that being the human beings, we can get the knowledge by several things. Means through observations we can get the knowledge, through communication we can get the knowledge, through problem solving we can get the knowledge, and through examples, when we are deriving certain examples also we can get some kind of knowledge. So in the same case, is it going to be the same in the AI machines also? So here being the human, our primary duty is we need to provide the knowledge to the AI machines so that it can show its intelligence. Means it will be our primary responsibility. So that responsibility is taken care by the specific concept which is called as here the expert systems. So we can say that expert systems main role is to provide the knowledge, provide the knowledge to the AI machines so that it can exhibit the intelligence. So in the sense, we can say that expert systems are nothing but the systems which are going to solve the problems that are solved by the human experts. Means how the humans are going to make use of their knowledge and try to solve the problems they have. In the similar way, even the expert systems are also going to follow the same kind of procedure. So to solve expert level problems, generally these expert systems need access to the sustainable domain knowledge. So that is important. As I said that expert systems main role is it has to provide the knowledge. So until and unless the expert system is able to have or acquire such kind of knowledge, then it will not be in a stage to provide it to the humans or to provide it to the users, we can say. So in this case, if the expert systems want to solve the expert level problems, means we can say most complex problems, then its primary duty is it need to acquire the domain knowledge. Here the domain knowledge in the sense knowledge to a particular problem, we can say. Means the domain can be a medical field, the domain can be some production, or it can be manufacturing. Okay, it can be some sales kind of things also. But until and unless the expert system has a specific quantity and quality of knowledge, it cannot provide it to the users to get solve their problems. So to solve such kind of problems, domain knowledge is very, very important. And also we need to explore one or more reasoning mechanisms also. So what is the need of this reasoning mechanisms? So if the expert system simply gives certain kind of solutions and the user is not going to convince with that solution. So what we have to do is, means what the expert system has to do is, along with providing certain domain knowledge and giving some kind of conclusions, it also has to give some kind of explanation, means some kind of reasoning, we can say, why that solution has been selected. Okay, so we need a mechanism for exploring what they have done to the users and who rely on them. And we can say that the expert systems are completely relayed, means the expert systems are completely dependent on the knowledge base. So we can treat that the knowledge base is one of the primary module of this expert system. So the expert systems are going to have certain knowledge which will be represented in the formal way, and that knowledge is provided by the domain experts. Domain experts in the sense, the experts, we can say the human experts, right? Means who are having an expertise knowledge on the particular domain. This information, means after acquiring the information or some kind of knowledge from the human experts, we are going to convert that knowledge in the form of rules. Means you try to understand the sequence. First, the expert system, they are trying to interact with the experts, means who are expertise or who are having a vast experience in that specific domain, and they will try to acquire some knowledge. That knowledge we are representing in the knowledge base, okay, which is one of the component of expert system, in the form of rules, and in the form of procedures also we are doing. But remember, the representation of the knowledge should be domain specific. Okay, means if you are working with different kinds of domains, then your expert systems should be different. Okay, so to incorporate these kind of informations into the system, it is necessary to make use of one or more knowledge representation methods. This is also important. Means first, what is happening, the expert systems, its primary duty is, it is interacting, we can say it is interacting, okay, interact with the human expert, we can say. So the human expert is going to give some kind of knowledge. Okay, some kind of knowledge will be provided, and this knowledge, okay, this knowledge we are trying to convert into rules, and these rules we are keeping in the expert system. Means we can say that expert system means, if this is the expert system, in the expert system, knowledge base is one of the component. Knowledge base is one of the component where we are going to represent the knowledge in the form of rules. This knowledge we have acquired from the human experts, means who worked on the specific domain for long period of time. So here, to incorporate these kind of informations, it is necessary to make use of the knowledge representation methods. Means here I have said that the knowledge is represented in the form of rules, but it's not it is not going to be very much clear if you represent this in the form of rules. So you should supposed to take different kinds of methods how we can represent the knowledge. Why? Because until and unless you represent the knowledge in a proper way, it cannot be useful for the users. So knowledge representation, we can say it is going to play an important role, so that the humans or the users can depend on the expert systems. Okay, coming to the structure of the expert systems, it is going to have different modules. In that, the primary modules is, one is the knowledge base, just now I informed, and also an inference engine is going to be there, and along with that, one more component, we can say it is called as a user interface. Okay, so what is this knowledge base? See, knowledge base is going to have, means we can treat them as a database, which is going to have huge quantity for knowledge to a specific domain. This is also very, very important. Means the knowledge base is going to have the knowledge which is related to some specific domain. So in this case, we can consider that for different domains, we are going to see different expert systems. So that is that is one of the component. And next one is an inference engine. So inference engine is the most responsible one in order to extract the knowledge from the knowledge base. So this extraction process will completely depends upon the questions that are asking by the humans. And the user interface, means user interface where the users are going to see the results, means outcomes which are coming from the expert system. So we can, with these things, we can say that here there is a user, right? There is a user. Definitely we can say that he is a non-expert. He is a non-expert. He's having an interaction with the user interface. This user interface again is going to have the inference engine, connectivity with the inference engine. So what this inference engine will do, it will try to continuously communicate with the knowledge base. So from this knowledge base, it will extract the knowledge, and that knowledge it will again give it to the user by providing it in the user interface. So now here we can expand this architecture also. How the knowledge base means, how the knowledge base will get the knowledge means by the human experts. Okay, so in the case we can expand this one by this one also. You can say that it is an expert. Okay, means the expert, expert system is interacting with the human expert and try to acquire some kind of knowledge. That knowledge we are representing in the knowledge base in the form of rules and also in different representations. And that knowledge, it is the expert system is extracting by using this inference engine. So whatever the knowledge that is extracting, that knowledge is kept given to the user interface that will make use by the user. So this is we can say it is a simple kind of architecture which will show exactly what are the different components that are present in the expert systems. So to be clear, we can consider these three components as are the most important components of expert systems. So one is the knowledge base, an inference engine, and the user interface. So let us talk about these modules individually. So if you talk about the knowledge base, we said that it is a collection of some kind of information, and that information also related to a specific domain, right? As I mentioned here, the knowledge base should have the knowledge which is related to only one particular domain. For example, if any of the expert system is developed in order to solve the medical kind of problems, so that expert systems knowledge base should have only information which is related to medical domain only. So if you want to include some other knowledge in the expert system, then you cannot make use of it. So you have to create one more expert system from the scratch. Means if I talk about expert system, then that expert system is going to have a knowledge base with a knowledge included, right, which is related to a specific domain. So it is considered as a storage. Even we can treat that one as a storage media also, means where we are storing the knowledge, and that knowledge is contributed by the different experts of the specific domain. This point is also very, very important. Means the expert system are we can say we are we are going to communicate with the experts which are to a specific experts related to some specific domain. Means the knowledge based knowledge is not acquired by only one expert. Means every time it is an iterative process. Every time we are continuously going to interact with the different people related to that specific domain, and we will try to acquire the knowledge, and that knowledge will be placed in the knowledge base. So we can say that the knowledge base knowledge is being contributed by the different experts related to that particular domain. So we can say that it can contain various facts about the domain as well as some kind of rules and methods that describes its relation. And we can also say that this expert system is also going to have some kind of ideas for solving problems in the particular area. Okay, so the acquired knowledge, it is not only going to give support to give some kind of decision to the user. Along with it, it is also going to provide some kind of ideas how that problem can be how a specific problem can be resolved. And after this knowledge base, the other component is the inference engine. So just now we discussed that an inference engine is it is an active component of the expert system. We can say it is going to make use of this knowledge. Means if you want to access the knowledge from the knowledge base, then that should be done from the inference engine only. So with this, we can say that it is a main processing unit of a computer system, or otherwise we can treat them it as a brain of the expert system. Okay, so it is used to deduce or derive new information or conclusions by applying inference rules to the knowledge base. So this point is also very, very important. Means first in the initial state we have interacted with the different experts, and collected some knowledge, and that knowledge we have kept in the knowledge base. And also we are trying to extract new information. We are trying to extract new knowledge, means the expert systems will try to extract new knowledge from the existing knowledge. Means it will try to generate new information from the knowledge it is already having. So in this particular aspect, inference engine is going to play a vital role. Means we can say that inference engine is functionality is not only to access the knowledge from the knowledge base, but also it will allow us to deduce new information from the existing one. So and also the primary thing is it is also going to support in deriving the error-free suggestions. Error-free suggestions in the sense at the end, means when the user is interacting with the expert system, the expert system has to give the final conclusion, means a final solution it has to give. So that solution, we can say that it is completely going to be error-free. Next one is the user interface. So this user interface will allow us to have a smooth communication between the system and the user. So it is also going to allow the user to gain the complete insight of the process that the inference engine is involved in. So we can also say that it is convenient to have this user interface. Why? Because the inference and the system are typically described as one module. Means we cannot say that inference engine and the user interface are the separate components. Those two are sorry, those two are considered as the same components itself. And coming to the representation and using of domain knowledge. So once we know how these expert systems are developed, so we should supposed to know how the knowledge to a specific domain can be represented. So we can say that the expert systems are more complex AI problems. Why? Because almost all the techniques, means whatever the techniques we have covered in the previous modules, those techniques are somewhat related to one particular expert system itself. Okay, so the most widely used such way of representing domain knowledge in the expert system is a set of production rules. Means just now we discussed that knowledge representation should be done by using different knowledge representation methods. So apart from that knowledge representation methods, there is a common representation method where the knowledge is represented in the knowledge base, that is in the form of these production rules. Okay, so even how these production rules are represented, that we will try to see in the upcoming slides. So we can say that okay, we can say that they are also often coupled with a frame system that defines the objects that occurs in the rules. Means we can say that in the productions, in the knowledge base, the knowledge we can represent in different ways. Means for example, we can represent in the form of rules, okay, which are having just like if then kind of things. And also we are going to represent the knowledge in the form of graphs. Okay, we are also going to represent the knowledge in the form of frames. Okay, we will try to see individually how this knowledge can be represented in the form of if then, graphs and frames by taking some suitable examples. Okay, so before taking the examples, let us try to understand some of the history related to these expert systems. So the first expert system, we can say that which is a commercial expert system developed by McDermott in 1982, and the name of that expert system is R1. So R1 it is a expert system that is developed in order to operate for Digital Equipment Corporation. So what this program will do is it is going to help in configuring the orders for new computer systems. Okay, so it will help in providing or in configuring the orders for new computer systems. So what is a advantage? Means what has impacted this R1 in this particular corporation? Means in 1986 it has been identified that the company has got a profit of almost $40 million a year. Means we can say that expert systems are playing a vital role, okay, vital role in improving the business also. So how these expert systems will work? Means it is not going to primarily work on the usage of match rather than, okay, it is not going to work on the match aspect. Okay, sorry, it is going to work on the match aspect, but it is not going to work on the generate and test. generate and test in the sense, expert system is not going to provide the solutions, okay, which you can do as a trial and error basis. You can use it as a trial and error basis, but it is not the case. So it is going to give you the exact solution, or we can say exact conclusion through which you can directly use it for your decision making. Okay, for example, you see, if you are implementing these expert systems in the field of medical industry, and if any of the patient is approaching to the expert system and asking for suggestion, so the expert system should not supposed to give different answers to the patient. So the expert system, by asking some kind of questions and trying to give generate some kind of reasoning, and it has to support the a patient with only one specific conclusion. So that conclusion, making use of that conclusion, the patient can take his decision. Okay, so that's why we can say that this expert systems, it is not going to work based on this generate and test procedure, but rather they are going to work on the match. Means directly a single solution will be given, that solution will be provided. Okay, and next, that is the same thing. Rather than exploring several hypotheses until a acceptable one is found, so what we are doing, we are trying to exploit its knowledge, and we will generate a single acceptable solution. We, in the sense here, the expert system. Okay, so if we talk specific about this R1, so what this R1 expert system is going to do is, it is going to take the customer's order as the input. Customer order as an input, and based upon that orders, it is going to generate some kind of diagrams, we can say. Means based upon the answers given by the person or the customer who is placing a new order for the computer system, and based upon that information, this R1 is going to generate some set of diagrams. Okay, and some set of diagrams which are going to include some objects and also some relationship between those objects. So we can say that, so what is the use of generating these kind of diagrams? So these diagrams are giving it to the technician. Means the people generally who perform this assembling of computer system, for those people these diagrams are given. So these technicians, by observing the diagrams, they will come to know whether all peripherals which are required for a computer system are placed or not. Okay, if it is not the case, means if any of the item is missing, means while assembling the things, if any of the technicians are found that some component is not available, so it will be very difficult to complete this assembling of computer system. So in that case, what happens, this R1, it is along with taking the customer's input, it is also going to see whether is there any missing component in the order. Means if such kind of component is missed in the order of the customer, then by itself it is going to identify such component, and it is going to add by itself in the order, so that the customer will not face any kind of problem while purchasing a new computer system. Okay. And coming to the examples of the expert system, there are few examples we are going to cover in this session. The first example, we can say it is a Dendral, okay, which is the earliest expert system, and it is completely we can say it is an AI project developed, and the main intention of this expert system is it has to perform the chemical analysis. Okay, it is going to perform the chemical analysis. So the expert system is going to means it is going to detect the unknown organic molecules based on their mass spectrum and the domain specific knowledge base. And another example related to the expert system is mycin. So we can say that this is the most popular and most we can say efficient expert systems which are developed in the earlier years. So this mycin, it is going to make use of this backward reasoning. Means it is not going to start from the initial state, but it is going to start from the goal state. Okay, so as it is starting from the goal state, it is going to generate some sub problems. Okay, it is going to generate some sub problems, and it will keep on solving those sub problems. And what is the intention of developing this mycin is, it is going to identify, means this expert system is going to identify the bacteria that is going to cause the infections like these two. Okay, and means the primary identification of these two diseases is the major role of this mycin expert system, and it is also going to suggest, right, when to take these antibiotics. Okay, when to take the antibiotics, and it is also going to help, means it is already proven that it is helped in suggesting the antibiotics usage, and also it is suggested, it has proved that it has identified, means by using this expert system, mycin expert system, even it will be very easy for us to identify the blood clotting diseases also. Okay, coming to the other thing which is called as expert system shell. Okay, so in the earlier cases, means we have seen this dendral and mycin. So these are the two expert systems, we can say, which are developed in the earlier years, and that too with the help of this list. With the help of this list. But after developing several systems, okay, means as I mentioned earlier, for different domains you should suppose to develop different expert systems. Means one expert system for one medical domain, another expert system for production, another system for manufacturing. It will be like that. So in this case, the people, they used to develop their own expert systems from the scratch. Okay, right? So it is to do in that fashion. But after developing certain kind of such kind of expert systems, it has been identified that there are some common factors, or we can say there are some common things which are covered regularly in all the developments of these expert systems. So they got an idea, means why can't we separate, or why can't we take that one separate from the developing aspect which is common among all the expert system development during expert system development. So it has been identified that okay, it has been identified that there is a thing which is called as interpreter, which we can separate from the development of these expert systems. Okay, means if any people want to develop a new expert system from the scratch, it's not necessary to consider this interpreter. Okay, so what they can do is they can concentrate on the other aspects of acquiring the knowledge and representation of that knowledge, and the interpreter they can make use from the other expert systems also. Why? Because this interpreter is very much common in all the expert systems. So we can say that that interpreter is nothing but some kind of shell. Now the question comes is, what do you mean by this shell here? Okay, we can say that this shell is a software application environment, or we can say software development environment, means where generally these expert systems are developed. Okay, so this expert system shell, okay, we can say expert system shell, generally where we develop these expert systems, it is going to have some basic components. It is going to have some basic components. So here, what are those basic components? The first primary concentration will be on the knowledge representation, and then the reasoning, and later the explanation. So we can say that SL is associated with a prescribed method for building applications for configuring and instantiating these components. We will come to know how these things will happen. Okay, so before that, we will try to concentrate on this knowledge representation, the reasoning, and explanation. Means while developing the expert system in the environment, in the development environment, we should suppose to concentrate on the knowledge representation and providing of reasoning, and also giving certain kind of explanation to the conclusion given by the expert system. Okay, so if you come to the knowledge representation, especially as I mentioned that in the knowledge base, the knowledge is represented in the form of rules. And if you clearly talk it, then we can say that the knowledge in the knowledge base can be represented in the form of if, then, else. Okay, even to be specific, we can say that it is if, then. So how it will be? Every knowledge, or we can say every rule, it will be represented in the form of if and then. In if, we are going to see some kind of situations, we can say, and if in then, we are going to see some actions or some kind of conclusions. So what does it mean? Okay, what does this mean? Means what is telling by this kind of knowledge representation? So we can say that if means if certain kind of conditions or certain kind of situations are matching, then what kind of action need to be taken? What kind of action need to be taken? For example, think that the user is looking for a decision, or he is going to think of whether he should carry a umbrella outside or not. So in this case, he can take the help of the expert system. So what the expert system will do, it will try to ask certain kind of questions to the user. So based on the answers given by the user, the expert system is going to give certain conclusion. Okay, so whatever the questions that are asking, that questions will be this one, A1, A2, A up to AN. Okay, so that we can say that this A1, A2 are nothing but some kind of conditions, means to that particular environment what are matching, or we can say some kind of situations. Okay, so we can say that in the example of this carrying of umbrella or not, in this case we can say that if, okay, if it is raining, it is one kind of it is not the condition, we can say that it is a situation. Otherwise we can say that it is we can say the temperature is high. Okay, temperature is high. Okay, these kind of things we will mention in the if. So when these kind of situations are matching, then what should be done? Then we can say that then carry umbrella. Okay, carry umbrella. So all the knowledge will be represented in this particular fashion only. Means if certain kind of situations or certain kind of conditions are matching, then what action or what conclusion should be given, what action need to be taken or what conclusion to be given. Okay, so this is one of the kind of representing the knowledge in the knowledge base. Okay, let us try to consider one more representation of the knowledge. How it will be in the form of a graph. Means as I mentioned, the one form of representing the knowledge is representing the rules in the form of if then syntax way, or otherwise you can go for the representation in the form of graphs. So in these graphs we are going to consider the objects, means the different objects that are involved in that particular situation, and also we are going to see certain kind of relationship between the objects. Means it is very clear that if you identify or if you mention any of the object in the knowledge base, then definitely those objects need to be in it need to have a relationship between the other objects. So the graphical representation of this knowledge, it is going to show some kind of objects and also the relationship that exists between those objects. So those relations we are going to represent, we can say are represent are denoted by a link. Okay, for example, think that there is one particular object. There are two particular objects. One is object 1, we can say, and another one is object 2, right? And if there is any kind of relationship that exists between this object and 1 and object 2, then we are denoting with a line. So whenever we represent this line or link, then we can say that there is some kind of relationship that exists between these two. Okay, so these kind of representations you can see in the one kind of knowledge representation, which is the graphs, the second kind of representing the knowledge, right? You can see this example. Okay, this example I have taken from your reference. I have mentioned the reference also here. So the most common form of semantic networks, we can say that the second form of representing the knowledge, means the knowledge we are representing in the form of graphs, we can say that it is a semantic network. Means in the semantic network representations, we are going to see several objects as well as the relationship between the objects. So those relationships either we are going to represent as is a or has. Okay, you can see this example. For example, if see here, if it is Honda and Nissan, for example, these are the two objects, then these two objects are having a relationship with the car. Okay, having a relationship with the car. Why? Because these two are the cars itself. So the two objects we have represented, and we need to means whenever we give a line between the objects, then we should suppose to mention the relationship also. So what is the relationship here we are mentioning is a. So what does it mean? Means Honda is a car, or otherwise we can say Nissan is a car. Like that it will be. Okay, so when we talk about the specific objects of a sub-objects of a specific object, then we can represent in this particular fashion, and we can say that the relationship is has. Means vehicle has the wheels, or the car has the engine, or the car has the battery. Means if you want to represent, means if for example if you are developing an expert system which is related to some manufacturing domain, so you should suppose to represent this knowledge in this particular fashion also. Okay, so during this case, means if you represent in this particular fashion, generally we are calling it as semantic networks. In these semantic networks, you can represent the objects which are involved in this one. Okay, we can say that this figure is related to some car car related expert system. Okay, or otherwise we can say it is a semantic network of a car vehicle. Okay, so in this case we can say that this semantic network is one kind of representing the knowledge, where we are going to show, or where we are going to represent the knowledge, all the knowledge in the form of objects, and also the relationship between those objects. And these relationships we are going to represent are either with a as a, or we are going to represent it as has. Coming to the third way of representing the knowledge. So in this technique we can say, okay, before this third technique we will see some more information about this one. We can say this one, what is this in this technique we can say knowledge is decomposed into higher module pieces. Of course, this is not the second way of representing, means there will be no graphical kind of procedure here, but we are going to represent the knowledge in a different way. What is that? Knowledge is decomposed, means the complete knowledge is decomposed into higher modular pieces. So what those pieces, we are calling them as frames. So representing the knowledge in the knowledge base in the third way is by showing in the form of frames. Okay, so this knowledge is going to consist of several attributes. It is going to have certain situations, and also going to have the relationship between the concepts. Okay, so it is also going to consist, means all these frames are also going to contain some kind of procedures which are going to handle the relationship between the objects, or relationship between the attribute values, we can say. Let us take some example and try to understand how this will be represented. So this is an example, again I have taken from this reference 4, and the two frames are represented here, and their slots filled with some data types. Means the second way of representation will be in the graphical form, and the third way of representation is in the form of frames. So in these frames it will be represented in this particular fashion. So what is a frame name and what is its value? Okay, otherwise we can say that what is a attribute and what is its value, or otherwise we can say that what is a object and what is a relationship. Okay, means in this case if you see is a relationship. Okay, if you talk about a vehicle and the engine, these two are the objects. Okay, so what are the values given to that particular object? So in this fashion we are going to represent the data. Otherwise we can say represent the knowledge. Means so far we have discussed that there are three different ways where the knowledge can be represented. One way is representing the rules in the form of if then kind of things, and the second way of representing the knowledge as a semantic network, where we are going to show entire thing as in the form of a graph, and the third one we can say that it is a representation in the form of frames. Coming to the other one, means once the knowledge there are three components in this expert system shell. One is the knowledge representation, and the second one is reasoning, and the third one is explanation. So we will try to cover this explanation now. So in order means for every expert system, right, if you say that it is an efficient tool, then it must be able to interact with it easily. Means any user, we can say, if the user can able to easily interact with the expert system, then we can say that it is an efficient tool. Why? Because if the interaction process makes more complex to the user, then that user is not going to concentrate or not going to make use of that expert system. Okay, so expert system is going to include lot of effort. So definitely we need to provide it to the humans, means need to provide it to the users. So we can say that whenever the people are making use of these expert systems in the most efficient manner, then we can say that the expert systems development is succeeded anyhow. Okay, we can expect the success of this expert system by showing the utilization of different users. Okay. So to facilitate this interaction, means in order to provide such kind of interaction, again this expert system need to have two capabilities. It's not only having the capability to give certain kind of solution or some kind of conclusion to the user's problem. Along with it, it needs to have two other components also. So what is that other components? One is it need to explain its reasoning. means why the expert system has given certain that kind of conclusion. Okay, right? And also the expert system should be in a stage to acquire the new knowledge every time by modifying the old knowledge. So this is also very, very important. So first, what the expert system is doing, it is trying to interact with the different experts, means who are expertise in that particular domain, and trying to acquire that knowledge and keeping it in the knowledge base. So we cannot say that up to this only the process is completed, means the development of knowledge base or the preparation of knowledge base is completed. We cannot suppose to say. So it is an iterative process. Iterative process in the sense the expert systems continuously need to refine the knowledge that present in the knowledge base so that it can show an efficient behavior. The expert system can show the higher level performance while serving the users. Okay, so the expert systems should be in a stage to explain these two capabilities of the expert system. One is it need to provide the reasoning, and also it need to acquire every time the new knowledge, and also need to modify the existing knowledge also. So explaining its reasoning. So in the reasoning means as we discussed, the people generally they are not going to convince with the results. Means if the expert system is just giving some kind of solution, and if it suggests the user that you have to follow this solution or this conclusion, then the people are not going to get convinced. So what the expert system's duty is not only to provide the conclusion or certain solution to the user, but also it has to give the reasoning also. Means what are the main reasons, or otherwise we can say what are the main conditions or main situations that are making the expert system to provide this kind of solution. Why? Because this is very, very important when we are dealing with the medical domains. Means until and unless we give certain kind of reasoning, the people are not going to get convinced. So in that case, the expert system means every expert system should have a meta knowledge. It should have meta knowledge, means it should supposed to acquire more knowledge, and it's supposed to have the knowledge again about the same knowledge. Okay, so we can say that having enough metadata about the process is also very, very important to ensure that the explanation of the steps are made. Means if you want to just provide some kind of solution or some kind of conclusion to the user, having a little quantity of knowledge is also more than enough. But when we are giving some kind of reasoning, means when the expert systems has to give the reasoning to that particular solution, then it should supposed to have lot of knowledge. So that knowledge acquisition is also one of the major role of the expert systems. So for each and every knowledge that knowledge base is holding, for that knowledge again it needs to have some other knowledge. Means until and unless it has a sufficient quantity or sufficient quality of knowledge, we cannot say that we cannot give certain solutions. That's why we are saying that every time we need to have some meta data. Otherwise, we are not going to provide any explanation to the steps that has taken by the expert system. And coming to the acquiring of new knowledge. So just now we discussed that acquiring of new knowledge and modification of old knowledge is also one of the functionality of the expert system. So how the expert systems can acquire the new knowledge? So the same process, that is every time the expert system has to interact with the experts related to that particular domain. Okay, why? Because the complete efficiency, we can say, the complete efficiency or otherwise the complete the richness of the expert system is completely depends upon its knowledge base only. Means how much efficient or how much quality of knowledge base that expert system maintains, so that much efficient that expert system will become. So every time, in order to provide such kind of performance, in order to show such kind of performance or efficiency, we can say every time the expert system has to keep on acquiring the new knowledge, and also it should supposed to modify the old knowledge also. Why? Because for particular situation one knowledge may work, and the same for the same situation in the other time it may not work. So in that case it should supposed to keep on modifying the old one. Okay. So it is very extremely important that those knowledge bases need to be complete and also accurate. Complete means it should supposed to have, means the knowledge base of the expert system should have enough quantity and quality of knowledge. Until and unless that knowledge is available, that expert system cannot give the accurate results. So one way of acquiring this knowledge is every time we need to keep on interacting with the human experts. So just now I told it is an iterative process. We should not supposed to stop modifying or adding the new data to new knowledge to the existing knowledge base. Should not supposed to stop. It is completely an iterative process. So every time the expert system has to continuously interact with the human experts. So if it is not the case, so there is another possibility where this knowledge can be acquired. That is the programs. The programs has to learn. Okay, the programs has to learn from the knowledge which is already available in the expert system. Now the question comes is, how are expert systems built? Okay, how are expert systems built? So we can say that the knowledge engineers, we can say knowledge engineers, every time what they will do is they will try to interview the domain experts. Means in the sense interaction will be in the form of some kind of interview, right? For example, we have developed an expert system to identify the cancer in the patient. So what the expert system will do, the expert system every time it will try to interact with the human experts, means we can say the doctors who are regularly dealing with these cancers, and it will try to keep on asking some kind of questions. Okay, so the expert systems will try to keep on asking some kind of questions to the human experts. Okay, that's why we are saying that it is some kind of interviewing a domain expert. Okay, so the expert system may ask for certain kind of symptoms, means when a doctor confirm that a patient is suffering from the cancer. So such kind of symptoms it is going to collect during the time of interview process. So whatever the symptoms are there, so and what are the reasons, reasoning also very, very important. Not only acquiring the knowledge, but also to reasoning also, means what are the main causes for that one. Okay, so both the things they are going to collect by doing this interview process with a domain expert. Once the sufficient quantity and sufficient quality of knowledge is acquired, then we are going to translate that knowledge into rules. Of course, rules are, we can say production rules are the most common way of representing the knowledge. Okay, so after the initial system is built, then we are going to perform the iterative process. Means the expert system, we can say continuously it is going to interact with the human expert, we can say, and it will try to extract some knowledge. So whatever the knowledge it got, that knowledge we can say this expert system is going to keep it in the make it as a knowledge base. So what does it mean? Initially this expert system has got some knowledge base. Okay, so we cannot say that this knowledge base, means initially acquired knowledge base is not so is perfect to give some solutions or give some kind of conclusions. So in this case what happens, we need to, means once the initial system is built, we need to iteratively refine the system until that particular expert system will show an expert level performance. Means the performance of the expert system is completely depends upon how that expert system is acquiring the new knowledge every time, and how it is modifying the old knowledge, and how it is refining the knowledge base is also very important. Okay, so refining of knowledge base in the sense we can say that it is also some kind of adding of new knowledge or modifying the existing knowledge also. Means until and unless the expert system refines its knowledge base, it cannot show the higher level of performance. Okay, so in the simplest form we can say that the expert systems are going to build by following some interview process where it is going to ask certain kind of questions to the human experts, means the experts in that particular domain, and once that information is acquired, that information will be converted or translated into rules, and once with that rules a initial knowledge base is going to be developed. Then later on an iterative process will be performed where every time we are going to refine the knowledge base until it shows, means until the expert system shows the higher level of performance. But this, as we said, that it is an iterative process. Iterative process in the sense we can say that it is completely an expensive and also the time consuming process. So as it is a time consuming process, then you should not you should suppose to have some automatic methods to do all kind of things. Okay, means getting new knowledge every time, Okay, refining the knowledge base and trying to interact with the experts, trying to acquire the knowledge, trying to translate that knowledge into rules. For all these activities, you should supposed to have some automatic ways so that everything will be done automatically. So with that, we can overcome the problem of this time consuming process. Okay, so there are, we can say that there are many programs that interact with these domain experts to have some expert knowledge, So in this case, that programs means whatever the programs which are available, that programs need to provide the support for these particular activities. Means it should supposed to provide, means the automatic program should provide the support for entering of knowledge, and also for maintaining the knowledge base consistency, and also ensuring the knowledge base completeness. Means the knowledge base should be complete before coming into effect, and the knowledge base should be always consistent. No inconsistency should be included in the expert system. And it should supposed to take care of even the entering of knowledge also. Means once we could able to automate these activities, then we can overcome the problem of this time consuming process. Okay, so the most useful knowledge acquisition programs, as I said, that it is always specific. Means whenever we are developing a certain expert system, so in the expert systems, the knowledge based preparation, it should be specific to that particular domain. Okay, so that's why we are saying that the most useful knowledge acquisition programs are restricted to a particular problem solving paradigm. Okay, problem solving paradigm, or in the simple words, we can say that it is a domain. Okay, so it is important to be able to enumerate the roles that knowledge can play in the problem solving process also. Okay, for that there is a specific, we can say a very specific program is there, which is called as MOLE. Okay, developed in 1988. So this program's main intention is it need to acquire the knowledge. So we can say that this is an automatic process or automatic program which can acquire the knowledge automatically. And this program, we can say this program is completely for the heuristic classification problems. Heuristic classification problems in the sense identifying certain kind of diseases. So in particular, if you talk in particular about this MOLE is going to use in conjunction with the cover and differentiate problem solving method. Cover and differentiate. So what does it mean? Okay, cover and differentiate means it is going to acquire the knowledge which is required to give certain solution to a particular problem. And once that knowledge is acquired, means once the expert system feels that it has acquired the sufficient quantity of knowledge, then it is going to differentiate. When just now we discussed that MOLE is going to, MOLE is going to use to in order to diagnose certain kind of diseases classification. So in this case, what it is doing, continuously it is going to acquire those things. Then once it is acquired, means once the knowledge is acquired, it is going to perform the differentiation. Okay, so this MOLE is going to accept the input data, and then that it is going to give, means the input data will be, the input data will be the data will be the input to this MOLE, and it is going to give with a set of some candidate explanations, or we can say. Okay, so these explanations are classifications that are going to cover or explain the data. So then it uses the differentiation knowledge to determine which one is the best one. Okay, so this is the way how this small program works. And here also the process is completely iterative. Why? Because the explanations must be justified. Means the reasoning whatever we are giving, or the explanations whatever we are giving to the solution, so definitely there should have some kind of justification. So that's why we say that it is an iterative process. So in this iterative process, what happens is we are going to give one kind of task to this program. What is that? It is called as MOLE P. P here nothing but it is a performance. Okay, so this procedure we can say that it is a interaction procedure with a domain expert. So why we are doing this interactive process means in order to create the new knowledge base. In order to create the new knowledge base, so that we can make use of it in order to solve the problems. Okay, so mole P is one of the procedure where we are acquiring the new knowledge by interacting with the experts. So this acquisition process, it is going to have several methods. Okay, several steps we can say. One step is the initial knowledge base construction. Means first our concentration will be on the knowledge base construction. Once we got an initial knowledge base with some quantity of knowledge, then we will concentrate on the quality of that knowledge. Okay, that is nothing but here refinement of the knowledge base. Coming to the construction, so mole is going to ask the expert some list of symptoms, or we can say some kind of complaints that might have arisen during the time of diagnosis. Okay, so for each and every system, means for each and every symptom, this mole is going to prompt some list of possible explanations. Means for example, there are some symptoms, for example symptom 1 and symptom 2 is there. For each and every symptom, again it is going to collect some kind of explanations. It is going to collect some kind of explanations. Why? Because until and unless we have a sufficient quantity of knowledge, we should not supposed to give these explanations. Why? Because reasoning is also one of the part of the expert system. Not only giving just solution, but also it has to give the reasoning. Okay, so we can say that it is completely an iterative process again. Okay, just now I explained, and iteratively it is going to seek out the higher level explanations. Means it is going to refine, we can say, refine the explanations until it is going to come up with a set of ultimate causes. Okay, so during this process, we can say that mole is going to build up a influence network. Coming to the refinement, so see, as I mentioned earlier, refinement in the sense, once you have the initial knowledge base, your next duty is you need to keep on adding the new knowledge, and also you should supposed to modify the existing knowledge. So keep adding the new knowledge, it is fine, but what does it mean, that modification of the existing knowledge? So when we go for this modification of the existing knowledge, means whenever we found it has been identified that the knowledge we have given, means we are having that knowledge is not suitable for us to give a perfect solution to the user. So in that case, definitely we need to modify such kind of knowledges. So modification of such kind of knowledges, even we say that it is a refinement process. So during this refinement process, again we are taking the help of this automatic program, which is mole program, where it is going to identify the weaknesses of the knowledge base. Okay, means where the knowledge base is not that much perfect, at what points. So it is going to identify, means some kind of approach it is going to follow. In that approach, it is going to identify the holes, and later on it is going to prompt. Holes is nothing but some kind of we can say inconsistency, or some kind of gaps, we can say. Okay, once it is identified that gaps, it is going to prompt the expert to fill them. Means whenever the expert system feels that the knowledge is not sufficient, then again it is going to interact with the expert, and it will try to fulfill that one. Okay, so before means before making this expert system available to the users, we are doing some kind of testing process, we can say. That testing process we are carrying out with this mole P. So what that mole P will do, it will try to continuously showcase its performance. So during that time, it is going to identify the incorrect diagnosis. So once any incorrect diagnosis is identified, it is going to extract the new knowledge, and that new knowledge will be added in place of the old knowledge. That is nothing but the modification of the existing knowledge base. Okay, so why we are doing all this one, means it is not going to have a sufficient knowledge about these various hypotheses. Means if the mole P does not have the sufficient knowledge to a particular domain, so it is simply going to reject some kind of hypothesis. But if that the hypothesis which is rejected is the correct one, then it will be very problematic for us. So in that case, definitely we need to make the refinement. So in simple words, we can say that refinement is nothing but identifying the weaknesses present in the knowledge base and trying to interact once again with the expert in order to fulfill that gaps present in the knowledge base. Okay, so this is all about the concept of expert systems, and The references that I have used during the preparation of this PPT is mentioned in this case. Okay, this is up to you. This is all about the today's session, and we will come up with a other topic in the next coming session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.